Hello. 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 Welcome to EduChat program. Today I will start linear equations, differential linear equations. You know it very well what is meant by linear equations. First degree equations in x and y is called linear equations in as usual. But in this differential equations, first order linear differential equation. First order, first degree linear equations. Now according to your syllabus I am going to call it as linear equations, differential linear equations. Linear equations an equation of the form dy by dx plus py is equal to q, where p and q are functions of x. An equation of the form dy by dx plus py is equal to q, where p and q are functions of x is called linear differential equation. Linear differential equation or simply linear equation in y. See, this is the linear equation in y. Dy by dx plus py is equal to q, where p and q are functions of x. This is called linear differential equation or simply linear equation. This is a linear equation in y. So now we will see how to solve this linear equation. First you have to remember, when the given differential equation, if it is not possible to solve by variable separable method, when the given equation is impossible to solve variable separable method, then we will go to the next method, that is linear equations. Then we will see whether the given equation is such type or not. Now we will see, when the given differential equation is in the form of this type, how to solve the such type of equations. Consider dy by dx plus py is equal to q. It is a linear equation in y. Multiply this equation e to the power of integral of p dx, where p is a function of x. According to this definition, we know it very well, this p is a function of x. Now multiply this equation both the sides by e to the power of integral of p dx, that is e to the power of integral of p dx dy by dx plus py is equal to e to the power of integral of p dx into q. This can be written as, look at the board, e to the power of integral of p dx into y. See, this can be written as e to the power of integral of p dx into dy by dx plus py, that can be written as derivative of e to the power of integral of p dx into y. Differentiate this. First one keep it as it is into derivative of the second one dy by dx plus second one keep it as it is derivative of e to the power of integral of p dx into derivative of this derivative and integration get cancelled, that is equal to p. Just you see that derivative of e to the power of integral of p dx into y with respect to x, this is equal to first one keep it as it is product rule, derivative of the second one plus second one keep it as it is derivative of the first one e to the power into derivative of integral of p dx, that is equal to e to the power of integral of p dx dy by dx plus y. Integration and differentiation get cancelled, we will get back the function p. See, derivative of this is equal to the same thing. So, therefore, this can be written as derivative of e to the power of integral of p dx into y. Integrate both the sides. Integrate both the sides. So, if we integrate this, integration and differentiation get cancelled, e to the power of integral of p dx into y integration of e to the power of p dx into q with respect to x. This is the solution of the linear equation. When the given equation is in the form of dy by dx plus py is equal to q, then the solution is e to the power of integral of p dx into y is equal to integration of e to the power of integral of p dx into q with respect to x, where e to the power of integral of p dx is called integrating factor. So, briefly we are going to write that is IF, integrating factor. The solution of the differential equation is y into integrating factor is equal to integration of q into integrating factor dx plus k. This is the solution of the linear equation. What type of equation we are going to call it as a linear equation? You remember that dy by dx plus py is equal to q. How to solve this equation? You have to remember only 2 points. First one, p is equal to what? Q is equal to what? And the integral factor is equal to e to the power of integral of p dx. The next point is solution is, this is the just like a formula you have to remember, y into integral factor is equal to integration of q into integral factor with respect to x plus k. This is only for the sake of understand I have explained. For the examination point you remember what type of equation we are going to call it as a linear equation and integral factor, the last solution of the linear equation. Now we will do the problems on linear equations. IF is equal to e to the power of integral of p dx. Integrating factor. First one, solve dy by dx plus y is equal to e to the power of minus x. This, whether it is a linear equation or not, first you see that. Dy by dx plus 1 into y, 1 means x to the power of 0. So, p is equal to x to the power of 0 is equal to q is equal to e to the power of minus x. So, it is a linear equation in y. Solution, given p is equal to 1 and q is equal to e to the power of minus x. Integrating factor is equal to e to the power of integral of p dx, e to the power of integral of 1 with respect to x. This is equal to e to the power of x. 1 with respect to x, that is equal to x. Integration of 1 with respect to x is equal to x. Therefore, the solution is y into integrating factor is equal to integration of q into integrating factor with respect to x plus q. This is equal to q is e to the power of minus x, integrating factor is e to the power of x with respect to x plus k. This is equal to integration of e to the power of minus x plus x dx plus k. This is equal to integration of e to the power of 0 dx plus k. This is equal to integration of 1 with respect to x plus k. 1 with respect to x, that is equal to x. Therefore, the solution is y into integral factor is equal to x plus k. Integral factor is e to the power of x. Y into e to the power of x, that is equal to x plus k. The solution is y into integral factor is equal to q into integral factor dx plus k. So, this is equal to, according to that, substitute the values, that is y into e to the power of x is equal to x plus k. That is the solution of the given differential equation. The second one, solve dy by dx minus 3 by x is equal to 1 over x squared. 1 over x squared. This is in the form of the equation. Directly it is given dy by dx plus py is equal to q. Therefore, where p and q are functions of x, so it is a linear equations. So, how to solve the linear equations? First we have to take the p is equal to what, q is equal to what. Then we have to find the integrating factor. Once if you find the integrating factor, solution is y into integrating factor is equal to integration of q into integrating factor plus k. So, p is equal to minus 3 by x, do not forget to take minus sign. Q is equal to 1 over x squared. Integrating factor is equal to e to the power of integral of minus 3 by x with respect to x, e to the power of minus 3 integration of 1 over x dx. This is equal to log x, integration of 1 over x with respect to x is equal to e to the power of minus 3 log x, e to the power of log x to the power of minus 3. This is equal to x to the power of minus 3. Remember that? Note, e to the power of log x is equal to x. This is very important in linear equation. Whenever we get e to the power of log x, that is equal to x. According to this, e to the power of log of x to the power of minus 3, that is equal to x to the power of minus 3. The solution is y into integral factor, integration of q into integral factor plus k, that is y into x to the power of minus 3, q is 1 over x squared into x to the power of minus 3 dx plus k. This is equal to integration of x to the power of minus 5 with respect to x plus k. Is it? X to the in the denominator x to the power of 2 is there. If it goes to the numerator, that is become x to the power of minus 2. Therefore, x to the power of minus 2 into x to the power of minus 3 is x to the power of minus 5. This is equal to x to the power of minus 5 plus 1 divided by minus 5 plus 1 plus k. This is equal to x to the power of minus 4 by minus 4 plus k. Therefore, the solution is y into x to the power of minus 3. This is equal to minus 1 over 4x to the power of 4 plus k. This is the solution of this differential equation. Now we will take the third one. Solve dy by dx minus 3 by x to y, that is equal to 2y squared, that is equal to 2y squared, that is dy by dx solution just you see the problem. Minus 3 by x y is equal to 2y squared is there. We know it very well. Dy by dx minus py is equal to q, where p and q are functions of x. But here p is a function of x, but q is a function of y. Let us see now. Dy by dx minus 3 by x, that is dy by dx 3 by x y plus 2y squared, that is dy by dx is equal to x is an LCM 3y plus 2y squared x. Is it? That is one minute please. 1 by minus, sorry, this is that is dx by dy. So given dx by dy minus 3 by x is equal to 2y squared. That can be written as dx by dy minus 3y 3 by x minus 3 by x is equal to y squared. Dx by dy is minus 3 by x into y is equal to 2y squared is there. That can be written as two y squared plus 3y by x. That is dx by dy 2y squared x plus 3y divide by x. That is minus 3 by x into y is equal to 2y squared. Actually this must be an x to the power of minus 1 divided by y squared. Dx by dy is given minus 1 over y by minus 3x by y into y squared. Sorry, here two problems are mixed, that's why I am getting like this. Just I will change this one. Solve dx by dy minus 1 over y is equal to 2y square. I have mixed two problems, that's why I have got it like that. See here, dx by dy. So the problem is in the place of dy by dx, dy by dx plus py is equal to q. It is a linear equation in y. But according to that, if I take dx by dy plus p into x is equal to q, where p and q are functions of y. Functions of y. Just you reverse this one. Dx by dy plus px is equal to q. That is a linear equation in x. Dx by dy plus px is equal to q. It is a linear equation in x, where p and q are functions of y. Here p and q are functions of x, but in this case p and q are functions of y. So p is equal to minus 1 over y, q is equal to 2y squared. Then integrating factor is equal to e to the power of integral of p dy, not p dx. Here in the place of dx we have to take dy. This is equal to e to the power of integral of minus 1 over y dy e to the power of minus log y is equal to log of y to the power of minus 1. This is equal to y to the power of minus 1. So e to the power of log x is equal to x. Similarly here e to the power of log y is equal to y. Therefore the solution is x into integrating factor. See, the solution is y into integrating factor, but according to this problem x into integrating factor is equal to q into integrating factor with respect to y plus k, not with respect to x, here with respect to y, that is x into y to the power of minus 1, q value is 2y squared, y to the power of minus 1 with respect to y plus k. This is equal to is constant y with respect to y plus k. This is 2 into y squared by 2 plus k. So when the equation is given in the linear equation in x, linear equation y, then how to change the formula? See, the solution is linear equation in y, y into integral factor is equal to integration of q into integral factor with respect to x plus k. But when the given equation is linear equation in x, then x into integral factor is equal to integration of q into integral factor with respect to y plus k. That we have to observe whether the given linear equation is given in y or in x or in any variable. So similarly we have to change the variables according to the rule. Therefore the solution is x into y to the power of minus 1 is equal to y squared plus k, y squared plus k, 2 get cancelled, we are going to get that is y squared plus k. The next one, dy by dx plus secant x into y is equal to tan x. This is a linear equation in y. This is a linear equation in y. Solution P is equal to secant x, q is equal to tan x, integral factor is equal to e to the power of integral of p dx, e to the power of integral of secant x is equal to e to the power of log of secant x plus tan x. This is equal to secant x plus tan x. E to the power of log x is equal to x. Therefore the solution is y into integrating factor is equal to integral of q into integrating factor dx plus k, that is y into secant x plus tan x, q is tan x integrating factor secant x plus tan x dx plus k. So now how to integrate this one? This is equal to integration of tan x secant x dx plus integration of tan squared x dx plus k. Multiply and split. So tan x into secant x plus tan x with respect to x. If you multiply these two, tan x into secant x plus tan x into tan x tan squared x. So this is direct formula, we know it very well. This is equal to secant x. So integration of tan squared x, directly we can't integrate secant squared x minus 1. This is the formula we have studied in our previous sum. And we know it very well, integration of secant squared x, that is equal to tan x. Integration of 1 with respect to x, that is secant x plus tan x minus x. Secant x plus integration of secant squared x with respect to x, tan x. Minus is there, minus integration of 1 with respect to x, that is x. Therefore, the solution is y into secant x plus tan x is equal to secant x plus tan x minus x plus k. This is the solution of the given differential equation. Let us see now. Solve x log x dy by dx, x log x dy by dx plus y is equal to 2 log x, x log x dy by dx plus y is equal to 2 log x. Solution. But we know the linear equation dy by dx, but along with that x log x is there. Divide the equation by x log x. We get dy by dx plus 1 over x log x is equal to 2 by x. So, P is equal to 1 over x log x and Q is equal to 2 by x. Integrating factor is equal to e to the power of integral of 1 over x log x with respect to x. Put log x is equal to t, 1 over x dx is equal to dt. This is equal to e to the power of integral of 1 over t dt, e to the power of log t, that is log x. Therefore, the solution is y into integral factor is equal to integral of q into integral factor dx plus k. Substitute it, we will get the answer, that is y into log x is equal to integral of 2 log x 2 by x into log x dx. Put log x is equal to t, differentiate with respect to x, 1 over x dx is equal to dt, t dt 2t squared by 2. So, this is t squared log x whole squared. Therefore, the solution is y into log x integration of RHS, that is log x whole squared plus k. Like this, first we have to form the differential equations, then we have to see that whether it is linear equation, then we have to take the p and q integrating factor, then according to formula you have to substitute and integrate the RHS. Okay, I will continue in the next class.